So hi, I'm doing this. Oh, it's a little echoey down here. I'm down in my basement. Anyway, I'm doing one about end behavior, and the idea is something may go on in the middle, but what we care about is what happens on the ends. Hence the name end behavior. And typically, we talk about what happens on the left side, which is when x is going to infinity. What happens to y, which we're leaving blank for right now. And as x is going to positive infinity, I think I said negative infinity over here. As this is the left side. The right side, as x goes to positive infinity, what happens to y? So we can usually probably have this situation, or we might have this situation, or there are two other situations we might have. We'll come back to this diagram. Once again, I'm doing this a little strangely. I don't have this on my tripod, so it may be a little shaky. Sorry about that. I've got a bunch of functions here. I've got x and x squared, and x to the third, and x to the fourth, and x to the fifth, and x to the sixth. And I'm going to get rid of the second, and the fourth, and the sixth. And what do you notice in common about all these? Well, they all start down in the left quadrant, the third quadrant, and all end in the first quadrant. And so our end behaviors, we can notice what happens on the left side and on the right side. And if I switch this back, I'm going to put in a second and fourth and sixth. So once again, those are those. And what you will notice is they are all pointing up. And what's in common with all those? Well, they all have even exponents or even degrees, whereas these have odd degrees, the other ones do. So it seems like we have a pattern where odd ones start down here and end up here, and even ones stand up to the top and end up top. But here, let me change something. I'm going to change that to a negative, and boom, what happens? Well, it simply reflects. So this rule kind of still works. We just have to know what happens when we put a negative out in front of a function, which we should know, is that when we put a negative out front, it reflects it. And so, boom, they're all upside down now because they're all negative. And the same can happen with like x to the third. So there's my x to the third. Let me turn off the other three. You can see x to the third starts down here and ends up there. But if I change that to a negative, put a negative out front, suddenly, boom, it flips. And we should expect that. We should know that behavior already. Now, this is for something really simple. This is the parent function. But I can change this even further. I can say, well, what if I made this, I'm going to make something up, x minus 2 and x minus 3, 4, okay? And we'll make it x plus, come on, plus 1. Okay. Now this is still the third power, because if I was to expand this out, I'm going to ultimately, my first terms will be x times x, that'll give me x squared, and eventually I'll multiply times x, it'll be x to the third. So this is still x to the third. And what happens is my middle behavior changes. I suddenly don't have a triple root anymore, I have 3 single roots, but it's still a third power. And because I still have the negative reflected, it still starts high and ends low. If I change this back to a positive out front, you'll notice still got the same zeros, so something happens in the middle, which I should recognize by my zeros. But now I start low and I end high, which is what I expect for the behavior of an odd function, because this is x to the third if I was to expand it all the way out in general form. And I can show the same is true as x to the fifth. So x to the fifth, I'm going to make this something a little crazy. I'm going to make it x plus 2 to the third power, and then I'm going to make it x minus 5 to the second power. I'll raise it again. Shift, there we go. Second power. So this is still an x to the fifth. Sorry, I'm a little blurry there. Because this will be an x to the third when I multiply everything here out. I'll have an x squared and an x to the third times x squared. Ultimately, it's still x to the fifth power. There's a bunch of other terms out there if I was going to expand all these. But as far as the degree of the function goes, it's a 5th degree function. So I haven't hit enter yet. So when I do, what happens? Nothing, because I don't have it turned on. So let me go back to here and turn this one off, turn this one on. And once again, we see the same behavior here. It's a little hard to tell, but it basically starts low. We have a wiggle where we have a triple root at -2, and then it goes way up high somewhere crazy. And then it comes back down and bounces at 5, which we expect because we have a double root -5, and then it ends up really high because that's an even root. So that's the basic idea. So a couple of ideas here you need to get out of this. First of all, before I go off the screen, just recognize, hey, x to the 3rd and x squared ultimately makes that x to the 5th. In this case, it is negative. So, oh, why does that not do what I expect it to do? It's negative. Oh, I just can't read it. It's not negative. It's an equal sign. That is an equal sign, not a negative. So it does start low and hit high. If I had a negative out front, which it kind of looked like, it would be it would start high and end low. But it is 3rd power squared. Ultimately, that's x to the 5th if I was to expand it all the way out. And so we're going to start low and end high because that's odd, as long as there's not a negative out front. So going back to our end behavior, the way we write this is just some special behavior, some special symbols we use for doing end behavior. So this means x approaches -infinity. This is one of the few cases we're going to read backwards, because x going to -infinity is this way. Normally we read a graph left to right. But in this case, we're going to say, oh, as x approaches -infinity, what happens to y, or f of x? And in this case, it's going to go to -infinity. Okay? On the other side of this thing, regardless of what happens in the middle, we don't care what happens in the middle behavior. This is end behavior. As x approaches infinity, so now we're reading from right to left. As x approaches infinity, what happens to y? Well, in this case, it goes to infinity. And this is going to be true of all odd functions. So that's x to the 3rd, x to the 5th, x to the 7th, so forth. As long as there's not a negative out front. If there's a negative out front, this behavior is going to flip-flop. It's going to be reflected across the x-axis. Okay, our other rule is as x approaches -infinity. So I'm looking to the left-hand side here, going out backwards. In this case, y is going to infinity. Okay, and in the same way as I go in this direction, as x approaches infinity, f of x or y is also going to approach infinity. I'm worried about the paper moving here. It probably is going to move. Oh, no, got it. Okay, so this is an even function. So it's like x, and the easiest way to remember this is the x squared. That certainly happens with, it just comes down in the middle. But we don't care what happens in the middle. What we care is what happens at the top. Okay, so if there's a negative out front here, we know both ends, they start low and end low. Okay, one last thing before we go. So I have this picture here. So first of all, is this an even or an odd function? And you should recognize that it is an even function because both ends end down. Actually, we probably know there's a negative out front because both of them end down. And assuming I can kind of identify what these roots are, I'm going to kind of make up what these numbers are, but this looks like it might be, I'm just going to guess a 3, and that's going to be a 2, and we'll just say that's 4. So assuming I can tell what these things are, this is probably negative x plus 3 squared, because it's the double root. This is like a wiggle, so that's probably a triple root. It's x minus 2 squared. And then the last one looks like it goes straight through, so that's x minus 4. This is definitely even. It is possible, oops, I didn't write that one right. It should be 3rd. I said 3rd, didn't write it. It is possible that maybe I don't see that one right, and maybe this is just a single root, but it's still going to be even. Because if it's a single root, that would be squared, that would be 1, that would be 1. So it's x to the 4th instead of x to the 6th. But definitely even, because both ends are ending down, and definitely negative because they're both ending down. If it was positive, they'd both end up. And this is nice too because this works in reverse. If you were given this formula, you could say, oh, I know I'm going to have a double root here, a triple root here, a single root here. I know I'm going to start, that makes it the 6th power. So once again, this is 6th degree. So we know we're either going to start high and end high, or start low and end low. And because there's a negative out front, we know we're going to start low. We're going to go up to the 3. We're going to come back down. We're going to go up to the 2. We're going to wiggle through the 2. We're going to end up on the other side. We're going to come back down through the 4 and then end low again. So these degree measures, these roots, and our patterns of even and whether it's negative or not, they should all reinforce themselves. And I think that's plenty. Ciao.